Claire permission. If Claire, I know that math is not the most important thing in your life. And that's okay. There are more important things in life than math. However, still got to learn it, right? So it's like, what should we do? So I give Claire permission when you start to feel drowsy, because we just had lunch, right? So here's what you could do. You could you could get up and walk around. B, if you just like sit upright and take 3 deep breaths, it will replenish the oxygen level of your brain. So like right now, Jack is going to be operating about 68% efficiency level for brain function. Okay, because he is not drawing in his full oxygen capacity, and oxygen is what you need to get the brain flowing, right? So, okay, guys, 68% is passing. Sounds like a winning attitude today. All right, here we go. You ready? Bunch of word problems. A man is walking away from a lamppost with a light source 6 meters above the ground. All right, I got a street lamp. There you go. It's my street lamp. The man is 2 meters tall. This is 6 meters tall. The man is 2 meters tall. And his shadow is, we'll say, 5 meters long. Sorry, haven't made all these changes yet. It says, how far from the lamppost is the man when his shadow is 5 meters long? Ooh, that's X. We want to know that distance, right? So, aha moment has to come. Good try. Yo. Good try again. Not gonna work. Yo. Yes, very good. Nice job, Darren. He sees it. Similar triangles. Go. Boom. So you have 2 triangles here. You got the one that's in blue and black, and then you have the green one. And he says that they are similar. They are similar because of angle, angle, angle. You see that these angles are shared, are they not? So those are the same. They also have a 90-degree angle. So if 2 angles are the same, does the third one have to be the same? And in geometry, you learn that by angle, 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 2 triangles are similar. And if they are similar, their sides are proportional. Height divided by shadow. What is the height of the lamppost? 6. What is that entire length on the bottom? We'll call it x plus 5. Equals, what's the height of the man? 2 over, how do I solve that? Let's multiply. 2x plus 10 is equal to 30. 2x is equal to 20. X is equal to 10. Does that answer the question? It actually, in this case, it does. 10 is x, and x does represent the distance from the lamppost. So 10 meters is the answer. You must have the appropriate labels. Because I changed it, and yeah, it would have been much more difficult. Yeah. Okay, now we're going to look at a problem that you can use similar triangles to solve, but it takes forever. So I'm going to use a new type of method called coordinate geometry in order to solve this. And it says that 2 flagpoles have heights of 9 feet and 13 feet. So we'll go flagpole 9 and flagpole 13. And it says that ropes are from the top of the poles. Ropes from. Just a bad day of notes. Ropes from the top of the poles are attached to the other's base. So I'm going to draw a rope from the top to the other's base. Rope from the top to the other's base. Question is, how far from the ground do the ropes cross? This is assuming that the poles are perpendicular to the ground, by the way. Oh boy. Not a lot of information, is it? So this is where I've learned a method as a teacher to invoke this coordinate geometry approach. What coordinate geometry is to take a geometrical shape and place it on the coordinate plane. So I'm going to create this sitting in the first quadrant, and I'm going to rethink the problem. I'm going to say that those two ropes are actually two lines, and that if we can find the point of intersection of those two lines, I will then know the height at which they are above the ground, right? Now, last year when I showed the group this problem, they thought that this was impossible, that they wouldn't ever really be able to do this on their own. They were wrong. They were able to do this on their own. So the first time you see it might look bad, but trust me, when you do it in your assignment and then on a study guide, you might say, hey, I think I could do this on a test. So let's write two equations for lines. I'm going to name these lines. We'll call one line M. We'll call the other line N. I'm going to go straight to y equals mx plus b because just by looking at these, I can tell what the slope is and what the y-intercept is. Let's start with line M. Can you tell what the y-intercept is of M? 9. Is that clear to everybody? So I'm going to have a plus 9 on the end. Now I just need the slope. What is the rise of point M from here to here, or line N from here to here? The rise. Close. Not positive 9, but negative 9, right? Do we know the run? No. So we'll create one more variable. We'll call it D. So I have y equals, so what is the slope now? Negative 9 over D is my slope, times x, plus, what's the y-intercept? Plus 9. Awesome. Okay, the next one, y equals mx plus b. What is the y-intercept of n? No. This is the y-axis. This is the x-axis. Where does this cross the y-axis? 0. What is the slope? The rise is 13. The run is d. So y is equal to, slope is 13 over d times x. Do we have a y-intercept? Just 0, so just leave it. Okay, so I wrote two equations for lines. We don't know what d is, okay, and that's all right. We'll just work with it. How do you find the intersection of two lines? You just set them equal to each other, right? I mean, they're both equal to y, so we'll just use substitution. We'll set them both equal to each other. So I've got an equation, 13 over d, and I'm going to write the x up in the numerator. It's x over 1, so I can just write it there, is equal to negative 9x over d plus 9. When I solve for this spot right here, the intersection, I'm solving for an xy coordinate. Okay? What am I trying to solve for right here? Am I solving for the x value or the y value? The x value. So I have to isolate x. So how am I going to solve this equation? What will I do first? I'm going to combine this over to this side, right? So how many x over d's will I have? 22x over d is equal to what? 9. Again, what are you trying to solve for in this problem? X. How do we get rid of the 22 over d? Times by d over 22. Okay, x is equal to 9d over 22. That's the x value. How do I find the y value? Plug it back in. So we have y is equal to 13 over d times x. So y is equal to 13 over d times the x value is 9d over 22. What do you notice happens? The d's cancel. 13 times 9, 117, 22. In this problem, to answer how high above the ground do they cross, is that the x value or is that the y value? That's the y value. So let's calculate 150 or 117 over 22. Somebody in your calculator, take 117 divided by 22. What do you get? 5.3. Okay. So 5.32 feet. That's how high above the ground. And we don't know where it happens, the x value, but we do know this. It doesn't matter how far apart they are. It's always going to be 5.32 feet. Now, raise your hand if you got lost at least a little bit somewhere in that process. Okay, good. Okay. Yes. Is what? Well, I decided that we were going to find the intersection of these two lines, and then that is a coordinate of x, y. So these two lines have these two equations. I set them equal to each other, and I solved for x, and then I solved for y. So that coordinate is that coordinate. So I don't know what this x value necessarily is because I don't know how far apart they are. But I do know this. The y value is 117 over 22. The y is the height off the ground. So here's what you have to do. If you didn't get the full thing, you got to go back and watch a video when you do your assignment. And trust me, if you see it again, you'll probably be able to do it. Okay? So that's just the way it goes some days, okay? And that's all right. Let's try an easier problem, okay? Tom is going to invest some money, okay? Yep. Good old Tom. He's got $9,600 to invest. He invests a portion of it at a rate of 4% a year. The rest he invests into a riskier market that earns him 10% a year. If his total earnings of the interest were $528, how much did he invest in each place? There's a record number of typos today in today's notes, so we'll just try to find them all. How much did he invest in each place? So this is what we call a mixture type of problem. From the beginning of our notes, we've seen consecutive numbers, we've seen area and shapes, similar triangles, and right now we're going to do mixture and money, and then we'll get to some of the other pieces. So mixture and money is kind of what's up right now, and when we have different quantities at different places, I like to provide some labels so we can understand what's going on. First of all, we have the total amount of money invested. Okay, how much money total did we invest? 9,600. How many different places do we put that money? Two. We put it in place A and we put it in place B. Two different places. Do we know how much we put in place A? Do we know how much we put in place B? Well, we know if we add A and B together, we should get 9,600. Now, that's one equation that's driving this problem. The other one is the amount of interest that we come up with. How much interest have we gained from this investment? $528. How much interest do we get from our investment in A? 4% times the amount of money invested. So if we invest $100, we're going to get $4 back. $4,000, you get $40 back. So 0.04 times the amount in A. Plus what? Good. I have how many unknowns? Two. Two unknowns requires two equations. Three unknowns requires three equations. Four unknowns requires four equations. Wait till you get to 126 unknowns. Then you need 126 equations, okay? Totally different scenario. So here, we just have two, no big deal. We got two methods of solving this. Do you know what they are? You got an excellent teacher last year. Elimination and substitution. There you go. What would you like to use? We'll do elimination the next problem. I like elimination as well in this problem, but the majority of the class last hour even said that they would like to do substitution. So we will do that. We'll say that B is equal to 9,600 minus A. What do I do with that? Plug it in for B. So 0.04A plus 0.1 times 9,600 minus A equal to 528 bucks. Now what? A tenth of 9,600 is 160 minus 0.1A equals 528. I can combine like terms here. 0.04A minus 0.1A, negative 0.06A is equal to, then I subtract the 960 over, 528 minus 960, negative 432. Divide both sides by negative 0.6. I think it should be 7,200. That's all right. $7,200 at what percent? 4%. Once I know A, how do I figure out B? Plug it into one of the knowns, and so it has to add up to 9,600. So we'll say $2,400 at 10%. How do you like that? Ooh, did I hear the E word? All right, we'll find a tougher problem for Jack. Yeah, we'll find a tough one for it. Okay? Because example 9 is a little bit different. What quantity of a 60% acid solution must be mixed with a 30% acid solution to produce 300 milliliters of a 50% solution? So what I have here is I want 300 milliliters. I got a bunch of 60% stuff. I got a bunch of 30% stuff. And I'm going to slowly add them together to fill this up and have it be a total of 50% stuff. Now, if I got one that's 60 and one that's 30, and I want 50 in the end, what am I going to have to add more of? What's going to have more added, the 60% or the 30%? 60, because it's closer to 60, right? Suppose it was 60 and 40 and we wanted 50. Well, then we would just add equal amounts, right? But it's 60 and 30, so we'll add more of that and a little less of that. But how much? That's a tough question, isn't it? We'll set up the same type of problem. We need a total amount, and we need an amount of acid. I say acid, and people's brains automatically just go to drugs. As though you guys go home and do a bunch of acid. I mean, really, like you're so, yeah, it was the same third hour. They laughed at the acid. They're like, it's like, you wouldn't know where to find it if you needed to, right? What is acid? Somebody help me out. What is that? What was my point? Okay, so acid, as in an acidic uh, substance that we're using in chemistry class. Okay, so how much total solution do we need? Hi, what do we need? How much? 300. So if I dump from beaker A and I dump from beaker B, how much total do I get? 300. So if I take the amount for beaker A plus the amount for beaker B, I get 300 total. Now here's the tough part. You got to think about this, folks. What is the total amount of acid that I need to have in my mixture? Okay, so this is the tough part. Before we gave you an exact number, 528, right? Now they're telling you 50%. Well, what is 50% of our total amount? 150. You see that? A little tricky. Tricky, tricky, tricky. Equals. What percent comes from beaker A? 0.6. What percent comes from beaker B? So now I'm going to invoke Darren's idea, which is to use elimination. I'm going to multiply the top through by -3. -3a minus 3b is equal to -900. And I'll multiply the bottom through by 10. 6a plus 3b is equal to 1500. What cancels? The b's. 3a is equal to 600, so a is 200. So we have 200 milliliters from or of what solution? Of 60%. And then B is what? 100 milliliters of 30%. Oh, you guys are smart. See, a very similar problem to the previous one, right? But the trick was you got to know how to handle the 50% piece. So it changes. Again, I can't possibly do enough problems so that you see examples of every single one. There's just too many. Okay? We have two more examples, then we call it a day. Okay? Yeah. Yep. 200 milliliters, 60%, 100 milliliters, 30%. That's our answer. All right. And paint a house. Anybody still have a house that needs to be painted? Anybody paint house? You're like your house is not permanent siding paint. Okay. Painted a room. That's nice. All right. What color? It was black. Painted room black. All right. Oh, a room. What is this room used for? Torture? Or black room. Wow. How about the color in our house is Oregon Coast. That's our color. That's what we like. Oregon Coast. So I'll try to get a picture of it to you later. All right. No, no, no. It's like a grayish green. I don't know. What? Goodness. Okay. We'll see you guys get thrown away here. So Mr. Jack Boondorf is saying this stuff is easy, so we'll see where his brain goes here. Jack, okay, John can paint a house in 32 hours. Eric can paint the same house in 24 hours. How long will it take them if they paint together? It's simple. You add them by 2, add them together and divide by 2, right? Why? Why isn't it 28? Why isn't it just 28? Okay, so Darren raises the point here that's important. It's not just 28 because Eric can paint it by himself in 24. So it's not going to take more than 24 hours to paint it, right? Suppose they both had a rate of 24. 24 hours to paint a house. Suppose that was both of their rates. How long would it take them to do it together? 12. So we know it's going to be more than 12, but we know it's going to be less than 24. Agreed? So at least we have an idea of where we're headed. So we're going to use a certain kind of formula here, and that is rate is equal to distance divided by time. When I multiply both sides by time, I get rate times time is equal to distance, or rate times time is equal to the amount of work that we get done. Whether you're talking distance or painting houses, that's the idea. Rate times time equals the amount of work done. Okay? So how many houses are they painting? One. And if we take the amount of work that John does and we add it to the amount of work Eric does, we will get one house painted. Who's going to end up doing more of the work? Eric, very good. So you got the idea. You're getting a reference for what's going on here. Good. So we need some rates because we don't know time, do we? That's what we're trying to figure out. So let's try to get some rates. The rate of John and the rate of Eric. John paints how many houses in how many hours? One house in how many hours? 32. That's John's rate. Eric paints how many houses in how many hours? Everybody with me so far? So the way that I get their work is I take their rate times time. So I have 1 over 32 times time plus 1 over 24 times time is equal to one house being painted. That variable t can go right in the numerator. T over 32 plus t over 24 is equal to 1. Now, how do I solve that equation? Find common denominators. So common denominator between 32 and 24. $96, but good guess. Thank you for answering, Jake. Excellent job. We got hey, nobody else answered, and you came up with the greatest common factor. Yep. Thank you. So what we're looking for is the least common multiple, and these both multiply to 96. How do I get 32 to be 96? So 3t. How do I get 24 to be 96? 4. Add them together, and I get. Whoops, sorry, because I'm an idiot. Over 96. It's okay. It's all right. I had third hour took some shots at me today. I deserved it. I was kind of mean yesterday. I was kind of edgy, but I'm happy today. Tenley told me to make new friends, and I have. So I'm gonna get rid of my fraction multiplied by 96 over 7. I get t is equal to 96 over 7. What is 96 over 7? Somebody. 13.7 hours. Now we said that we would have to be between what two numbers? Aren't we smart? Gonna make lots of money someday. Last example. Then we wrap it up. We have Matt and Sue, and somehow John interjected himself back in the problem. So we're going to go back to Matt. Sorry. Matt and Sue can paint a house in 5 hours if they work together. Small house, okay? If Matt can paint a house twice as fast as Sue, how long would it take Matt to paint the house alone? I mean, this is, we got to still set up the problem the same way, which is rate times time is equal to work. How many houses are they painting? They're painting one house. So again, we have Matt's work plus Sue's work is equal to 1. The amount of work that Matt does is his rate divided or times time. Do we know the time for each of them? Yeah, they're spending 5 hours working together. So now we just need to come up with expressions for rates. Well, we have the rate of Matt and we have the rate of Sue. If Matt does one house every H hours, then Sue does one house every 2H hours. That makes sense? Watch. Don't get mad at me. There's multiple ways to set up the problem. The other way you could do is say, well, let's say Sue did one house every H hours, then Matt would do how many houses every H hours? So whether you set up the problem with the blue or the black, it'll work out the same. I mean, there's a lot of ways to set these things up. So I'm just trying to choose the one that helps explain the problem best. Okay. All right, here we go. Matt's work. Times time. So 1 over H times, what's the time? 5 plus 1 over 2H times 5 is equal to 1. Or 5 over H plus 5 over 2H is equal to 1. Find common denominators to multiply top and bottom by 2. So I get 15 over 2H is equal to 1 over 1. I then added the 5. Notice the H is in the denominator, so I have to cross multiply. I get 2H is equal to 15. Divide both sides by 2. H is 7.5 hours. Now, from here, so H is in the denominator, so you can't simply multiply by 2 over 15 because you'll have 1 over H left. So I cross multiply 2H times 1, 2H. 15 times 1, 15. So now H is 7.5 hours. Does that answer my question? What is the question? Matt. So I'll plug that 7.5 in for his rate. That means one house every 7.5 hours. So that is the answer. How long would it have taken Sue? 15. See the difference? I get that these aren't easy. You guys, all I can do is just try to expose you to as many as we can and then have you try to practice on your own. So here's what you want to do. Yesterday, we talked about doing problems, what was it, 1 through 8? So now you can do everything up until you might want to skip problem 14. I would come back to that last. Not many people get problem 14. I would really appreciate it if you tried it and gave it your best shot. That said, a lot of people don't. How many people get it? You don't have to do 14. Yeah. Okay. All right. I answered your puzzle earlier this year. It honestly took me 6 minutes. I was sitting in calculus class and the puzzle was up on the board. They're like, what is that? I was like, oh, I need to do this. I haven't done it yet. And Jack's been bugging me about it. I sat down 6 minutes. Boom, the answer. There you go, buddy. Step up. You're exactly right. It's more of a riddle. That's not. Well,